This animated diagram shows a corporate organizational chart. You would assume a network flows cleanly from executives down to entry-level staff. But suppose a rogue hacker, Dark Knight, breaches a low-level marketing computer. His ultimate target is the backup server, where full system snapshots are stored. Looking at this flat, hierarchical list provides a false sense of security because there is seemingly no direct access between the marketing department and the backups. In reality, years of IT patches and inherited permissions have turned the network into a tangled, invisible maze. Stopping the attacker is impossible unless defenders can see the actual hidden pathways. To find those pathways, a defender's first tool is PowerView. Think of it as a digital sonar pinging the Active Directory environment. PowerView queries LDAP, the protocol used to access and maintain directory information, to rapidly ask the network who is logged in and what groups exist. The incoming results from this query arrive as an overwhelming, chaotic flood of raw text and dense data logs. Here is the defender's dilemma. Dark Knight is moving fast. Attempting to read through thousands of lines of text manually guarantees the attacker will win the race to the backup server. When response time is measured in seconds, raw text logs become a bottleneck, stalling the defense while the attacker remains mobile. We translate that data using BloodHound, an analytical engine that turns raw PowerView text into a visual map. BloodHound operates on a mathematical framework called graph theory. In this animated diagram, you can see the basic framework. We have nodes, which represent the individual users, the circle, and the computers on the network, the square. Then we have edges, which represent the specific permissions and trust relationships connecting those nodes together.
A practical example of an edge is a low-level user accessing a standard computer, where a domain admin left an open, hijackable session. When we conceptually zoom out, we can see how thousands of these nodes and edges interact, revealing the network's true scale. BloodHound's primary defensive function is parsing this web. We can execute a search for the shortest path to the backup server. The software highlights the specific multi-step route the attacker is destined to take through this chaotic environment. A graph model identifies the specific high-risk intersections where a single misconfiguration connects a guest user to a global administrator. Back in our scenario, Dark Knight has aggressively advanced to the third step of the mapped 5-step path. Using the map, the defender rushes ahead to the fourth step, revoking the specific inherited permission connecting the nodes. The attacker attempts to pivot to the next step, but hits a severed connection. The backup server is secured. Amateurs attempt to secure networks by thinking in lists, while professionals secure networks by thinking of graphs. True cybersecurity requires auditing complex internal trust relationships. To follow along with our next lesson, install BloodHound in your legal lab environment so we can map these networks together.